Hello everyone, in this video I will show you our new product, that is KC868 M16. This board is mainly used for monitor the sensor state of the energy meter. So you can see there are 16 channel CT sensor. You can see this is CT sensor input and also made by the ESP32. So this board also will support the Home Assistant by ESPHome and support you write any Arduino code downloaded to the ESP32 module. And also you can see here is the SD card socket, so that you can use the SD card, insert to this socket and remove the SD card. And this SD card is no memory limit, so it's according to your Arduino code, because the Home Assistant not save the history state in this SD card. The Home Assistant will save the sensor history date on the Raspberry Pi on the server. We have designed this board for the ESPHome so that can easily integrate to a Home Assistant. You can see here, this is our phone, and here you can see the dashboard. We have created the CT clamp energy meter by this board, and here you can see the first channel that have showed the measured current and power and how many energy have consumer. So you can see this is the full date of the channel 1, and this is channel 2 until channel 16. And there have 3 channels of the analog input of ESP32 GPIO pins. So you can see here that have 3 pins, 3 channels of analog input not detected by the energy meter, just from DC 0 to 5 voltage sensor you can connect to this part. And this is the Home Assistant. This is YAML file you can download, and we have created this file. You can easily copy and paste using Home Assistant. And about the SD card, we can also support the Arduino source code. You can use this SD card to read and write any date. You can see we have created the Hello World demo source code and how to write the SD card and read the SD card. So you can use this Arduino code. And also this board is supported by the ESPHome. You can see this is ESPHome official device have list. At here you can see that is KinCony M16 have added to this platform. And also you will see many related board of the KinCony. You can see that all is supported by the ESPHome. And click M16. This pin define and configure YAML file, and all have created. Okay, this is the software supported by the M16 board. Let's look at the hardware details, and you can see this board have some details. You can see every pin, every channel, and every function on this board, on this diagram. Before you want to monitor the voltage and the current and the power, maybe you will install the power meter. This power meter, and we'll install the power distribution box. And this is the demo photo, have connected with the KC868 server and monitor the RS485 Modbus energy meter. But this time we have another way. You can see here we can use the CT sensor. Just use this sensor, because the different sensor will have different type. You can see the range is different, is 100 ampere. So this is big and this is small, and this output is voltage, and this output is current. So these are 2 different type of the sensor, CT sensor. And in our board you can see if you want to use the voltage or use the current, just change the jump. If you can press at this right sections, that is V. That means the voltage sensor. If you want to use the current sensor, you just change to the left. So you can see there are 16 jump for 16 channel CT sensor input port. So that will be easy to set. Just choose different range of the CT sensor and just change to the jump. Okay, this is CT sensor, and you can see that support max 16 channel CT sensor. You can just connect to this socket, any socket you can use. So if I can connect with this one, and this is another channel, so just like this, and just choose the jump, set to left or set to the right, and go on. We can see you just use this sensor and fix on your WAN. So this can be easily to monitor the WAN you have installed in your house or in your building. That will be not change your WAN. So you can see that the M16 board have detect when WAN. Okay, this is another way you can use this CT sensor easily to monitor the current. And this you can see the power meter, you can see the voltage have detect, but the CT sensor is merely detect the current. Okay, let's look at the hardware details. You can see we have designed this board, and here is our schematic. The board also is open source. You can download the schematic from KinCony's website. You can download from here, document, and you will find the M16 schematic. So you just click, and we have already uploaded the PDF file. So you will easily to understand some details of the hardware design. And this is our PCB board, and this you can see the 3D, and this is the back, and mainly the components at the top of the PCB. And here you can see that is LCD display and the RTC module. So you can see here that have LCD display, SSD1306, that's supported by the ESPHome. So you can plug in at here. So maybe you will write the Arduino code to show the current and the voltage. And you can see we will use this metal and to fix the display. And also you can see this RTC socket. You can see like this. I can fix it here. And the display, you can see I can fix it here. So you can use your screw to fix by this hole. So if you can write the Arduino code, you can save your sensor data and to the SD card and read the data from the SD card and display on the screen. So that is up to you if you can write code. And this PCB board also support install to the plastic shoe. So you can see we open this box and can install the PCB board to this shoe and just close it, and you will see this is in front and this is left and this is back, and this is another side. And also you can see this box that will support install on the DIN rail. So you can see I can use this easily to fix to the power distribution box. Okay, now I will show you how it works with Home Assistant. We will use this appliance for a test. You can see this board I connect with the Ethernet cable, and I choose this 15 ampere the current, because if your current or line is large current, so you can choose another one, maybe 100 ampere. But this time I will show you I have connected to the channel 1, and this is channel 1. Just plug in. Okay, and this USB cable you can download the firmware and you can monitor the state. I just connect it here. And this is the power line. We have connected with 12 volt DC. Also you can connect with 24 volt DC. So you can see I just plug in it here because the terminal is removable. So that will be easy to connect to the WAN. I will connect at 12 volts. And the last, I have made this power socket, but I have cut the line. And this connect to my power supply, and for 220 volts AC, because I want to use this CT clamp and just like this to fix it, so that can detect the WAN, the current. Okay, you can see that is red LED. I have connected this power socket to power, and now I will connect with the 12 volt. So I can connect with it, and you can see the red LED is on. And this is channel 1. And here you can see that is my mobile phone of the Home Assistant. It have been refreshed. You can see here I have some information that is seen as the PC software. Now we can see our Home Assistant dashboard. If you first time, you just need to create the device in ESPHome, and I have already created the M16 and edit. And all is very simple. Just copy all config file and paste it here. So when you can just click and download by the USB cable. And after you download, you will see your board will become online. So you can see that is online because I communication with the Ethernet cable. And go to the dashboard. I have created the dashboard. You can see the current channel 1 power and total energy. Because this have some value, you need to calibrate. So this is very important. You can see the calibration of the CT sensor. That will be very important. Just add many lines, such as when the output logo, the RAW value is 0, and this is 0 ampere. This is 4 ampere, and what is output from the logo file. Later I will show you how to do this. Now I just test for you. You can see I will use this one and connect to this power. And now you can see I can start. I can start and become hot. This will become hot, and you will see this current is changed, and this power is calculated, and this is energy consumer, power consumer, and this is for the channel 1. So this is began work. If I disable the warmer, just not from the warmer, so you can see here that will become smaller. So this is for channel 1. We can detect by this current, power, and the energy. So you can see also I can use the Home Assistant application by my mobile phone. So you can see the value is changed. And also we can see the history. You can see the history and this history. You can also click the computer, the history and the history and the history. Okay. This is detect from the PC software and the mobile phone. And also it can use by the tablet for the Home Assistant. And this you can see that is Amazon tablet. So we can open this box. You can see also is the Home Assistant. See many value, and you can see here. That is the Home Assistant dashboard at here. If I turn on, and you will see the date is changed. So you can see the date is changed. I can also click and follow history and follow history. Okay, this is work for the tablet. And now I will show you how to calibrate. This is very important. So you can see our ESPHome, and you can see that M16, and you will find these two values. That means 0 ampere. That means 8.9 ampere. So you just need to measure when the 0 and what output from the debug information, and what is this value from the logo file output. So you can add this line 1, line 2, and line 3 and line 4. Just for many lines that your value will be better. This is our M16 board help create. You can click the logo file and click this by the USB because I have used this USB cable and connected the Raspberry Pi, so you can see here, and click USB serial, so that will be output the date. Because I have set every 5 seconds and update the value, so we can, it's always fresh. You can download the logo file and open this file, and we can find the channel 1. So I can use the find function and measure current channel 1. So you can see the RAW value just without any load. Now you can see the circuit without any load. So this should be 0 current. So that is the value 0.004. So we can copy this number, copy and paste to your file. So we can find that is 0 ampere. So you can use this value or maybe other value. So this can be calibrated when this sensor without any load, that is have a value output from the CT board. And this you have connected a loader, and what is the date output from the logo file, and you maybe you will add the 3 or the 4 or the 5. So maybe you have let this become 1 ampere or 3 ampere or 5 ampere, and you need to monitor what's the date output, so that if you have many lines about the calibration, so your date of the current will be better. So this is how to calibration, and the details you just see the ESPHome official website. That here have many details. Okay, if you have any questions, you can leave a message to us. Thanks for watching.